problems already. Thank you all for being here, and thank you all for being here. I am going to quickly introduce, so usually I'm very nervous about public speaking, but I'm among friends, so I feel pretty good about this panel. And so I'm going to briefly introduce what I know of my friends, and then they will talk about what are the things that they're working on today and how they're innovating and changing the world. So Andy Champagne is a dear friend of mine for nearly 2 decades. We worked together when we were like 8. So Andy is the CTO of Akamai Labs at Akamai Technologies, one of the world-leading CDN of the world, but they're also growing. And Andy is truly an innovator, a technologist, and a business visionary driving the next step in what Akamai is going to be doing. But beyond that, a great friend of mine. So Andy, why don't you tell everybody what you do at Akamai?
No, thank you very much. I don't know how much I can really add to that. So, my role at Akamai is to run Akamai Labs, which is kind of the research and development arm of Akamai that is working on building and constructing new solutions for Akamai to scale out. And Akamai, first of all, exciting topics to talk about here because Akamai is all about the edge, really. That's been kind of our mantra since inception, is on being hyper-distributed. And it's really great to see a critical mass forming around that. So really my work is around, how do we bring new and innovative solutions that are perhaps a bit different than traditional content delivery to bear. And that's what I spend most of the day and my team working on. And glad to be here. Thank you.
Great. And here's another dear friend, Najim. Najim runs the network for Facebook. Just in case you guys are not familiar with Facebook, they're a social network. So I don't think that requires much explanation what Facebook is, but prior to joining Facebook about 8 years ago, Najim also was the GM of Microsoft's network. And before that, there was this network that I think it was quite old. It's called UUNet. If any of you are old enough to remember, Najim ran UUNet's network as well. So Najim, why don't you tell us what innovation you're working on at Facebook?
Thanks. Glad to be here. If you think about web scale companies, most of the time we get known for large data centers and building massive infrastructure from a data center perspective. Thanks, Zachary. The interesting thing about social networks is that if you look at our user base, 88% of our user base is actually outside the US. And sometimes people are like, wait, 88%, how is that possible? Actually, if you do very simple math, look at 2 billion plus people, how many people are actually in the US, even if you say everybody in the US has a Facebook, Instagram, WhatsApp account, you still account for only 300 million some people. Rest of them are outside the US. What that fundamentally means that we build a fairly significant edge all around the globe. There isn't any country where we don't have users. And so our job becomes to make sure that we're providing a user experience to every user in the world. So it's actually far more challenging than it seems at times, where you're thinking about a user sitting in Indonesia on a BlueBerry or a BlackBerry. They still use a lot of BlackBerry because it's kind of really interesting how Indonesia market happened, where BlackBerry went in big, gave everybody phones, and what they did was went to Facebook. And so now we have all these people trying to connect to Facebook over really, really bad networks and phones. So we have to know what the mobile handset they're using, what networks they're on, and how we connect to them, and what services we can provide, and how do we improve the user experience that they experience on a day-to-day basis. So Edge is actually fundamentally really, really vital to our business on how we provide the services. So there's a lot of things that we do in that space.
Great. Last but not the least, Zach Smith. Zachary Smith is the CEO of Packet Host, and Packet Host is one of the most innovative edge bare metal cloud platform. And prior to co-founding Packet Host, Zach also started a company called Voxel, and he was the COO at Voxel. And Voxel is one of the most innovative hosting companies in the world. So he's got, and they sold to Internap, and he was handcuffed to Internap for a year or so before he started Packet. So why don't you tell us what are the exciting things happening at Packet?
Thank you. So, as Jezebel said, I'm mainly coming from not the biggest delivery network in the world or not the biggest social network in the world. We have a tiny little startup called Packet, about 50 people. We're 4 years old, and we focus on a very fundamental problem, which is automating single-tenant compute infrastructure across different architectures, x86 with Intel and ARM, x86 with Intel and AMD, and various ARM architectures. And we do it for a developer user. And so we really believe that compute is getting more diverse, not more generic, and that the use cases that these people are talking about, and I'm sure that other people are trying to do, are causing people to move past what I like to consider the generic worship of the giant Intel machine and moving into highly specialized coprocessors, offloads, and more diverse hardware, not less. That's pretty antithetical, I think, to the general consumption model that most people use infrastructure right now, which is generally in a abstracted, virtualized manner. And so what we're focused on is how to normalize the experience of consuming hardware for a user who has never touched that hardware and will probably never touch that hardware physically. We think that also leads to that hardware being in more places. So I happen to believe that, and what we'll talk about today, there's certainly a latency or experience or network equation related to moving hardware into more places and the gravity that's associated with those networks. And there's also, you know, a secondary, which maybe I might believe more, which is around economic factors. So love to talk about more as we get into the use cases and what we're seeing in the customer base.
Great. And I'm just going to kick off the session by giving you a little bit of my thoughts, and then I have a bunch of questions loaded for these industry experts for their insights. So we live in an age of constant changes. Changes hopefully are driven by the data that's being collected of all of us to make smarter decisions. Data is being collected every second. I want to give you an example. Hopefully this is somewhat relatable. I travel on business all the time. A few weeks ago, my husband asked me while I was on FaceTime with my son chatting, he said, hey, just in case if you're thinking about buying more toothbrush heads, we actually have a whole bunch still in the back of the cupboard. It took me by surprise for a second because I'm thousands of miles away. I did, when I was on the airplane, look at toothbrush heads on Amazon because I thought that we might need some. But how would he know that I looked at it? So I think he saw that surprise on my face, and he's like, oh, they recommended some add-on items on our joint Amazon account. So I thought you might be looking at toothbrush heads. That is the kind of data that's being gathered of all of us. And those are real-time data that's being fed back to trigger an action. Right? So think about that. Why am I telling you about this particular experience? Communicating our intent to a varying degree is something that we do, everyone does all the time. Often, we don't think about it at all. You use your blinkers to turn in the car. And if you don't, right, if we don't communicate our intents, many things could go wrong. We could get into traffic accidents, marriages could fail, and traffic could go out of control completely. And in my case, unnecessary items could show up from Amazon all over my house. And nearly everyone in every business today are integrating technologies and integrating with technologies at a breakneck pace. So setting a course for significant scale in the coming years to become or remain relevant and competitive. In fact, Gartner predicted that by year 2020, IoT will connect 20.4 billion devices worldwide. I don't know if that registers, but there are 10 zeros in 20 billion, okay? That's an enormous number, 3 commas in there. So with or without the Internet of Things, businesses have access to more information than ever before, and they're using it to rethink how they operate. The idea of enabling business to use data to make smarter decisions help build stronger relationships with customers and improving speed and agility in responding to urgent needs. Edge computing in itself is not a new concept. Placing computing intelligence in nodes at the edge of a network for the purpose of industrial automation has been common practice for years. However, the level at which devices are now being networked from the field to corporate environments is rising to a point that's never seen before. This morning, in this particular room, Jack Waters in the keynote spoke about the many driving factors of the increasing demands in infrastructure capacity. The historical method of capacity planning for business demands has been vastly over-provision. Just buy a lot more than you need. However, the peak and the mean of traffic usage are getting closer and closer together. So you are no longer be able to over-purchase because there's an economic downside to over-purchase your network capacity. So how are you going to do that and at the same time bringing the edge that we are all talking about to meet the core? So with that, I'm going to say there's a blurred line between the edge and the core. I'm going to start with one of the most important questions, which is, how do you define the edge? What does that mean to your company? So I think that's a question for everyone, and why don't we start in this direction, and Andy can start.
I get to start? Thank you. So first of all, on the blinker comment, I'm from Massachusetts in the Boston area, and up there, using your blinker is a sign of weakness, and you will not be allowed to merge. So I don't know, it's pretty much the same thing in New York from what I've seen historically. So to talk about what the edge is, and I'm going to use kind of Akamai's parlance in terms, but I think it'll be interesting to hear the different perspectives. So first of all, I would define, and I think Akamai would define the edge as where the consumption happens. And that means a lot of things. Typically, that means where the humans are. And that could be you holding your cell phone. You are now the edge. Enjoy that. Or it could mean you at home with your IP set-top box watching a stream off some OTT provider. That is also the edge. So very likely it's where the consumption happens. Now I think the pivot on that, where it's not just where the humans are, is that more and more data is being consumed by machines. And that could be IoT or other modes of communication. And in that case, there's kind of a secondary edge, which are IoT-style devices that are also consuming data. They're receiving feeds, they're taking actions, they might be letting the humans know by sending push notifications to their devices. But I think that I'd start with the postulate that the edge is really about where people are or where machine consumption is happening. And that the true edge, if you're sitting here and you've got your phone, that's the edge of the network from, all kind of common nomenclature that we'd also use. So I'd start there and maybe be interested for thoughts of others.
You went off script. Before the panel, we were outside and we were talking about how are we going to spice this up. And we decided edge is overrated.
Booze.
We're not going to do this.
Do it with booze.
Well, no, before that, this was an infrastructure plan that we're going to forget the edge. That's all overrated. We're going to buy land, a whole state in the middle of the country, and build one large data center. Serve everybody from there. Thank you very much.
We're saving it for later.
Okay. So let me just extend sort of my view of the definition of edge that you described, Andy. And there are essentially, when you have devices, you have those devices, you have to connect them to the network somehow. And that's the network edge that is actually collecting a lot of data or providing that access mechanism. Lots of people call it access, some call it edge, some call it other sort of terms in that. But really where the devices are and how you connect them, how you provide them connectivity is one. The other edge that I think we're talking about it here more is the edge that serves the end user in the end, and how users connect and consume services. And the way sort of we think about the edge is that there are two really important things. One, how we improve user experience, whichever service the user is trying to get to, how do we improve that experience in terms of speed, reliability, availability, things like that. And second, how do we reduce the cost of delivering that bit? That's important. So that's sort of how we think about edge is, can we collect all the data that we need to collect or provide connectivity to every user out there? And then the second part is really, can we improve the user experience while actually reducing the load on the network itself? Because the more load you create, the more congestion you cause. So that's sort of the simple definition for us.
Mine's a little bit different because we don't operate, again, big platforms and big social networks. We help other people consume and leverage infrastructure. So I would actually point back to, I think that there's probably, and correct me if I'm wrong, 30 or 40 or 50 companies in the world that operate applications in a highly distributed manner at the edge of a network, right? You got CDNs, you have telcos, you have a couple other people, maybe big, social networks, but not a lot. And I think that the question that we're trying to help answer, and I believe, I've probably been on 24 panels in the last 6 months about edge compute, which basically everybody's really excited about because there might be a lot of dollar signs for somebody in those areas, or at least people imagine there may be. And I like to think that, first and foremost, that the user of, or who's creating applications, we're here in the infrastructure world. There's a couple tens of thousands of people who care about infrastructure to the degree we do, maybe. And there's tens of millions of developers or people who like software in the world. And I think more and more of those people are creating applications that live with opinion, whether that's location or network points or whatnot that they care about. Most people don't care enough to do anything about it because right now it's really expensive to put applications at the network edge. And you have to have this massive amount of expertise on, we were talking earlier about doing log aggregation is a huge part of Akamai's network, and they don't get paid for it, but they have to do it, and nobody, very few people have that kind of skill set. All right, so I think what we're trying to help with is, and how we define the edge, is effectively an enterprise opinion. Right? We believe that enterprises have lots of opinion about where things are, what matters to them, where they want to put it at what time point, et cetera, because they are building a business off of some sort of a technology opinion. So for us, it doesn't matter whether you want to be like Facebook and put application delivery close to every wireless network in the world because you have users all over the world, or you're just in Vermont and you care a lot about Vermont and you don't care about the rest of the world at all. I think that this is the interesting part, whether you take it to a stadium or you take it to a city or the law tells you you have to be someplace. We think edge basically equals enterprise opinion. And the question is how do we as an infrastructure ecosystem, hardware, networks, co-location, turning on and off machines, putting them in places, powering them with networks, how do we make that consumable to a developer or a modern millennial consumer who barely wants to own a car, let alone deal with racking or stacking or powering networks in Vermont. I think it's more likely that they won't ever do that. So the question, I think, comes down to, are you going to have 10 or 20 companies in the world who define the opinion of edge and how that works like as platforms, and you get to consume those and maybe innovate way up here or maybe try a little bit down here, or they're going to be, is there going to be a more diverse subset? So I think that's the ultimate question we're interested in, and that will define for me where the edge equals.
Very different responses. I hope you're getting it all in. So I'm actually going to start the next question with Zach, because I think this is an important one. Why does it matter? Why does edge matter? Everybody's talking. He's been on a dozen of panels in the last few weeks.
Yeah.
Everybody's talking about edge.
So here's the best way that I've been able to describe it, right? Beyond, hey, I really care about Vermont and I really want to put my application in Vermont for some reason. We probably all got up this morning and what's interesting about us is that we brought something around with us everywhere. Hopefully, we brought a little bit of intelligence with us. We brought our brain, which is not actually very fast. It's chemical, right? And so it's not nearly as fast as all the stuff you guys all build, which is electrical. And so we have these things that are sensors, like our eyes and our hands and our ears and whatnot, that take in information. And we have a lot of those in the world today around IoT, right? We have sensors and cameras and cell phones and all kinds of stuff that consume information. But what we don't have is a highly efficient brain. Because the brain that we have, we probably have a couple espressos and, a donut, and we can walk around all day, and we don't need much more than that to think. But for a data center, in order to be as smart as a human, we need like a couple megawatts. And then it's really hard to bring that around. And so the question that I like to look at is, if we're all spending all this time building radio networks that are super close to people and we're gonna basically wire up every little street corner on the planet, are we doing it so that we can quickly like our friend's post? No offense, right? Does that change the world? It did. Is it gonna change it more over the next 5 years because we're live streaming as we click those posts? I don't know if that's gonna do it. So I think the interesting opportunity is, can you bring the intelligence that is being created, whether that's in machine learning, in applications that people are creating, and bring it closer to your sensors so that you can have experiences that change people's lives, right? And to do that, we will probably need to put that brain closer, and we're probably not gonna carry it around in our pocket unless somebody changes the battery technology. So that's my answer on why it matters. If we can't actually change people's lives by creating an experience that kind of tricks the human brain or replicates intelligence, build a big data center in the middle of one state and call it a day. Do it cheap.
So let me extend your answer slightly, just because of scale. You mentioned 1 to 2 megawatts. We built in 150 megawatt chunks. So the kind of compute that is required for the amount of data that is collected these days, you actually can't do it even with 1 or 2 or 10 megawatts. You need tens of megawatts to actually run compute like that. So in our perspective, your premise is the right premise. What ends up happening is you collect a lot of data, then you actually ship it to large data centers where you do massive compute, and then you're pushing that information that you've learned to the edge so you can serve the end user in the end. Yes, you may do some more compute at the edge as well, but you have to find that balance on where it makes sense to actually do the compute. And different services or different applications use a sort of different model. Some things are centralized to large data centers and some things are more distributed across the edge. But that's sort of the scale conversation that comes in at times.
And I'm going to add and refine, since I get to do that, right? Which is basically, this is essentially my thesis that we are not going to be dealing with generic compute, right? Because generic compute takes too much power. We will not be able to put sufficient computing capacity in places that are near the users, whether those are the machines or the humans, without highly specializing that compute so it's more efficient at what it does. Otherwise, we will have to have tens of megawatts in localized cities. I don't currently believe that that will exist, so I believe we will have to have highly specialized compute. Open the floor for arguments.
So on the compute angle, I think a lot of this comes down to the applications and the application design, right? So really, we're here at an infrastructure event, but this is really an application question, because I would perhaps disagree with you. We can continue the discussion later, but the notion of compute at the edge is very powerful, but it's very powerful if an application is written with the intent of using it in that way. And the challenge is that almost all the applications we have today are not. And I'd offer maybe my perspective on I think the initial question, which is like, why are we pursuing the edge? And it's really about, at least from Akamai's definition, right? It's about optimizing performance fully. Performance of the internet in general still kind of sucks, right? I mean, that's kind of the unwritten rule. It's better. It's much better than it was if you didn't use it in the late 90s. It's much better. But it's still not good. And that is largely due to the long distance between you, the user, aka the edge under my definition, and the stuff you're trying to get to, the content, the resources, the applications. So by trying to pull those physically closer together so that the thing you're trying to get to is more co-located, if you will, with you, and not necessarily in the same building, but at least in the same metro area, and at least on a provider that you can reliably talk through. That's what is going to lead to improved performance and experience. I know I went really technical there, but I think that that's where you're actually going to begin to see a differentiation, is when applications are physically closer. Having one, our joke line of having one data center, you can build the best data center in the world. But if you only have one, it's going to be really slow if you're on the other side of the planet, purely due to laws of physics.
I'm going to pick on your customized point a little bit as well. The trouble that you end up with is when you start building the edge and it's fairly large and distributed. We're in 68 some countries with edge presence. If you start doing very customized, the problem is if your workload and your services change and you need a different level, a different type of compute, then the upgrade process is really, really cumbersome and difficult. So yes, I agree in some cases that you need specialized compute, but those things have to be use cases that are sort of well-defined and understood. So like video transcoding, right? We do that a lot. We ingest a lot of video, we need to transcode it. You know what that is, you can hardware accelerate it. You can build customized hardware. But to serve all the different services or all the different applications a product group may come up with, which they haven't even thought of today yet, they might drop us something tomorrow. How do we serve that from the edge? That becomes a really hard conversation in a very customized compute model.
Yeah, I mean, I totally agree. Probably, how long did it take you to build 60 points of presence around the world?
A lot. Yeah, a lot of time.
Yeah, and probably obviously it's like really hard to upgrade even generic compute in Indonesia, let alone specialized compute. It's actually pretty hard to upgrade generic compute in Boston. So I mean, if you're just doing a couple racks.
That was a low blow, Andy.
In New York, right?
Akamai.
I mean, whatever. I mean, Akamai knows this problem, right? Because it has compute infrastructure in how many countries, right? And I think what the interesting topic here is that both of these use cases, for even putting that relevant amount of infrastructure across the globe, is essentially for one or two pretty well-defined applications, right? I mean, you're serving Facebook.com and WhatsApp and video streaming and a few others, right? And you're doing primarily content delivery and a few others. But this is like for a pretty well-defined application. And I think that this is fundamental to my premise, is that I believe there's going to be a wide diversity, maybe it's not thousands, but it was definitely hundreds of different types of applications that are going to require infrastructure that is somewhat specialized, if not highly specialized to what it does. And the question is, how does that happen? Because it's really hard to put servers in a Boston data center if you're not doing a hyperscale L11 rack topology today and ordering 100,000 a month. So how do you do that when you want to put it in every city? You guys in the DAS world are trying to do this right now in different places with radios. Those are pretty specialized little computers. Mm-hmm. So I think that there's a gap, without a doubt, in terms of infrastructure delivery for hardware, whether that's in the United States, in a second-tier city like Minneapolis, or Indonesia. It is very hard to put special things in places.
I couldn't agree more. So, and you see very diverse point of views from everybody, but I think the consensus here maybe is there's plenty of opportunity for additional infrastructure services because of this development of edge. So
I think there's a lot of opportunity in it. I just think it's not going to look like a bunch of little Equinixes, right? It's not going to look today how data centers look. because it is simply going to be too expensive and too hard for us to deploy in the increments that we need to.
You know what I'd say to that, and I'm not sure exactly what it looks like. I would say that I would clearly agree with you that the infrastructure of tomorrow is not going to look exactly like a continued stamp out of the infrastructure we have today, and that it's continuing to evolve. And I think we're seeing that from a hardware perspective, we're seeing that from a networking perspective, and I think that's going to continue. In 20 years, it'll be super interesting to see what the data center topology of the internet looks like. I think that the core premise that I'd say from an edge is that it's going to be more distributed versus less. And I think that's the kind of shift that we've seen as we went from, in the late 90s, you have 1 or 2 data centers and providers that are long gone that I won't even name, and now you build an app in a distributed way, and maybe you run it in different Amazon availability zones or however you're doing. So people are starting to move in that way, and I think that's going to continue for performance reasons.
Certainly, I think software, and you've seen the cloud native movement, whether you guys follow the Kubernetes work that's happened or just highly distributed schedulers that are effectively doing, and I'm not even going to say it like highly distributed, right? Let's just use something that people can actually operate in 3 availability zones. Mm-hmm. That's hard for most developers. It is becoming a lot easier. I would say that compared to what it was 5 years ago, we have 16-year-olds with their mom's credit card on our platform deploying in 20 locations globally using Anycast networks, which was impossible 5 years ago for them. I'm not going to say that it's trivial right now, but certainly this is becoming easier in software. It's not becoming easier in infrastructure.
To Zach's point, right? I see personally that applications being developed because of the new existence of edge compute that is so much easier to consume, right? There are new things that could be developed that doesn't exist today, that Facebook did not exist, and look how big they are today, right? And it wasn't that long ago, I was a Friendster user, and I can't believe I just admitted that. But, when Facebook became popular, did you know that it was going to be what it is today?
But here's the question I have. Facebook probably started in a single data center, maybe just a couple racks in some Harvard dorm room or whatever, right? I don't know, a server. Okay, so it used to be in his place. But when you're trying to build around location, like this becomes a very expensive science experiment, right? To say, right, we don't know what the application is, let's build the infrastructure and they will come. That's not possible, right? Even with just like generic x86 computers in all the markets that matter for the edge of the internet is an impossible situation for almost any company, not only from a cost perspective, but just from a time perspective, right? And so it might take you, if you went to Equinix and go in their 200 data centers, how long would it take you to deploy hardware? I don't know, like 2 years in all of them? So I think that's why you don't see a lot of new CDNs competing beyond other hard stuff. And I think this is going to be a different phase where there's going to need to be more of an ecosystem to support people to actually experiment and try, or we're going to sit around trying to guess some killer app, which is probably not going to be the way that it works. So you guys can create the killer apps, though.
Yeah, I mean, I think killer app is a misnomer. Apps happen often when infrastructure exists, or killer app comes in, infrastructure happens because of that. Waiting for it's no sense doing that. The interesting thing that's not happening today is that there's edge compute infrastructure that's available that you can actually rent, which is sort of, I think, where you're starting to play. And as that gets more, you're exactly right that it takes a lot of time and effort to actually build applications that are geo-distributed, have several fault domains, and that stuff is going to get easier. If you just look at just the cloud and cloud penetration, 5 years ago, nobody actually cared about the cloud as much. Now it's really hard to find a startup that doesn't start with the cloud itself. And the point is that the cost to get started is so high trying to build infrastructure yourself Cloud is a lot easier to do. And then more importantly, to me at least, that it lets you focus on your product rather than focus on infrastructure to start with. Once you get to a size that it makes sense, that infrastructure becomes that expensive, or you can't just use a service that becomes very prohibitive, then you start building your infrastructure and you start gaining some benefits out of that. I think the edge is going to follow the same pattern, where edge will start becoming that facility that will be then used by a bunch of developers. I could use Akamai as the same example. In the 2000 timeframe, there was no CDN, and people used Akamai as a CDN, pretty much all of it. And Facebook started the same way. We didn't have our own edge presence, and we used Akamai a bunch to serve that. And I think the sort of compute side of the edge will follow the same pattern.
So now we talked about why edge is important. Edge has a lot to do with mobile, right? Everybody has a mobile device. Can you guys help us understand what mobile networks need to do to adapt to enable closer proximity of 5G and edge computing to be closer to the application and IP transit networks?
Sure, I'll take it. The thing about mobile networks is that they have touch points with the IP networks that are too far apart. If you look at a classical mobile network, you have towers, you have backhauls, you backhaul to some POP somewhere. And it's really expensive to build a lot of POPs, so you have very few POPs. Most networks will have, a couple of dozen POPs in the entire country, and essentially home all the mobile towers to those POPs. So what that means is that if the two of you are talking, sitting next to each other, you're actually going to the POP and coming back. And there's round-trip latencies that cause delays, or the user experience suffers in that scenario. So the question really is, how do we actually move IP closer to the IP endpoints closer to the end user? And that has to change over time, and that is changing as time goes on.
To just add to that, totally agree. And one word to watch out for, if you're talking about edge and you hear backhaul, that is like kryptonite to edge, right? Anytime you hear backhaul, that means like, wait a minute, it's not really the edge, right? And it totally makes sense why the infrastructure is as it is, given how it has evolved. But we definitely need to get to a place where backhaul is minimized, and the notion of, there's large cellular carriers, large mobile carriers in the US that have a handful of egress points to the actual internet. That's going to have to change by orders of magnitude, especially with things like 5G, where you're going to start to see consumption go through the roof, because it's not practical. And frankly, you're not going to get a good application experience either with someone like Akamai, who's in those networks, with Facebook, who has wide points of connection into those networks, or anyone else, if you're only actually talking to the internet from a half a dozen points inside the continental US.
I sometimes use a very mundane example. A lot of people work in large companies with pretty strong hierarchies. Just imagine or count the number of layers you have to go up to find your peer on the other side. If you can just talk to the peer directly, that's the fastest. If you have to go to your manager or manager's manager and manager's manager or your CEO and then come back down, it'll be next year. So.
Very relatable.
And that defines
experience.
the LTE network, huh?
So with the world going mobile, do you foresee the wireless carriers surpass the wired carriers in capacity? And what are the technologies required to make that happen? And what are the technology improvements?
Yeah, I love wireless. I'm a wireless guy, but wired is critically important and will remain critically important for a long time, simply due to spectrum issues and just how much you can physically push. Inherently, when you're dealing with wireless, you're dealing with a shared technology. In wired, you can move to a technology where it's not necessarily shared. And I think that when you start to talk about home use and business use. And specifically, if you think about traditional cable TV, and you think about that all going to IP, and your cable box no longer exists, but you have your Amazon Fire, your Roku, your Apple TV, pick your device of your choice, and all consumption around the world is based on that. I think that there's got to be a large component that is based on wires, simply because I don't know, and I'd be happy to be corrected, but I don't know that there's a technology that's going to allow performant, reliable, VOD, non-synchronized live. So it's everybody watching what they want when they want. It's not watching 10 channels. I don't know that there's a technology that's going to do that in 1080p 60 or 4K 30 or 4K 60 that's going to be based on wireless. I think 5G is going to do amazing things. I think it's going to do amazing things for our handsets, but I think that a significant portion of the infrastructure, I think, is going to stay wired. And candidly, also just from a subscriber or user perspective, the wired infrastructure has been comparatively unbounded compared to wireless infrastructure, which is bounded. Which is like, if you're a Verizon or T-Mobile or AT&T or whomever customer, you have a data limit, and it's like they're super helpful and they have apps and you get like 10 gig or whatever. You might have a limit on your wired infrastructure, but it's probably an order of magnitude or more data that you kind of get for your monthly allotment. So I think wired's going to continue to play a big role in the future.
So the only data point I have is I teach a class at PS2, 7, and 6 public school that my kids go to for the fourth graders. And I teach them about how the internet works, which is really interesting to teach to fourth graders because they're like aware enough and they've got devices and whatnot. But the first thing I'd always do is I ask them, how the internet works, and they all look like you're a complete idiot, right? And so what they tell you is that the internet always works, right? Like it's like, on my iPad, the internet works, and that's literally their consumption mode. So from a fourth grader standpoint with no filter, they are pretty sure the world is all wireless today, right? They say the only time the internet doesn't work is sometimes it's slow on the plane. Of course, these are New York City fourth graders, so, they've got all the getchy gummies. But yeah, I mean, we're going to build a lot of wires, but I think the consumption model for most things are going to be wireless.
And just to clarify, I would consider Wi-Fi wired.
Sure.
Sorry, to make that.
Yeah, I get it, right? I mean, backhaul, evil, kryptonite.
Yeah. The only thing I would add, and just being the backbone person sometimes I end up being, is that whenever you talk about backhaul, you can't beat wired. From a wireless perspective, capacities you can't touch. If you come in the data center, we don't do wireless, period. Yeah, your laptop works in the wireless, but all machines are connected to wires, to fiber, essentially. In terms of speeds and capacities, you can't compete with a physical cable. So wherever you need massive amounts of backhaul, massive amounts of capacity, wired tends to be the one that wins. Wireless obviously is a lot easier and to deploy and manage, and you see that, and that's the experience that you're going to get, is where you have way at the edge where the end user is, where the people are, you're going to see more and more wireless, and you can say Wi-Fi is wireless or not wireless, but at some point it's going to backhaul into a wire, and that's going to continue.
So I think that the big question here is like, well, who's going to control your backhaul, right? And who's going to be giving you, who's your ISP, right? And I think that is maybe the crux of the question, is that more than likely beyond the MSOs, you're going to see more wireless carriers servicing your home or your connectivity, especially if you're a fourth grader and you think it's just always on in your pocket and that's how the internet is, right? So I think there'll be a shift to more of the interconnection being driven by wireless carriers and being less important with the fixed carriers. I mean, I care much more about my peering and interconnection with, T-Mo than I do with level 3 at this point. I mean,
That makes sense, especially for future looking. But for the people in this room, I want to pose a question to you to think about, which is there an opportunity in the DOS and small cell world to create a new network that isn't necessarily just cellular, that is a combination of Wi-Fi and cellular?
is CBRS considered Wi-Fi, or is that considered
Well,
this one? Cellular.
so,
Yeah, exactly.
so that's something I want to leave you to think about. But since we're running out of time, I'm going to move to the last question, which hopefully you will find interesting, which is, we talked a lot about data centers, backhauls, right, and the edge. So are the current data centers and backhaul networks evolved enough to embrace the edge? And if not, what innovations would you and your companies like to see emerging?
I'm happy to offer my opinion, which you guys can then refute. I think that the data center architecture today is really a holdover of the initial data center. And I'm going to pick on Northern Virginia shamelessly, which is, back in the late 90s, Northern Virginia was absolutely critical for the internet because AOL was there. And the amount of dial-up termination in the racks upon racks upon racks of total control hubs that they had in their data centers to terminate dial-in users was massive, and it was a tremendous percentage of the internet ran to Northern Virginia. And then as a result, we've got Equinix Ashburn, back before that May East, and the various kinds of interconnection points around there. And obviously AOL's no longer terminating a lot of dial-up in Northern Virginia. There's still stuff in Northern Virginia, but we have a lot of infrastructure there that doesn't seem to match where the population center really is, but the infrastructure's still there. And if you look at Equinix, I don't know how many buildings are they on now, like in Northern, like they can't, every building down 12 or something. So there's just a tremendous amount of capacity that's data center capacity that's in places for historical reasons that is no longer necessarily as relevant from a user perspective, but it became and remains relevant because that's where the fiber was and that's where the infrastructure was laid. I think that from Akamai's perspective, companies that are doing small, agile data centers where you are deploying into areas that is not simply a newer, cheaper data center next to an existing one, but in areas where previously there was no IP, where you're kind of bringing in a new area where you can terminate, whether it's in a second-tier city, third-tier city, or internationally, emerging markets is a huge area. So that's what's useful to us, is where you can open up a new node in that edge where we can actually put in equipment and start servicing user requests from there.
So I guess I'll add from a data center point of view, the underlying fiber infrastructure sort of doesn't match where the data center is being built today. Andy reminded me of May East. How many hours did I spend in that little garage? It's literally in the garage of a building. If you think about sort of how the interconnection exchange points or even the Equinix locations were picked, I remember early days in UUNet, the way we built it was, let's go with NFL cities, because we didn't know any better how to pick which cities to go build POPs in. So we picked NFL cities, and all NFL cities have POPs, and that's where the fiber is. Now, if you think about data centers, one of the data centers we built is in a town that has a main street which is half a mile long with one McDonald's and one gas station. That's it. That's the entire town. So it's out in the middle of nowhere. There's really not much else going on there. It used to be a potato chip factory that we took over. Another one we built up in Luleå, Sweden, where in the winter the sun just doesn't show up, or the summer sun doesn't go down, however you like it, and it's way out there and there's no fiber there. So the fiber footprint is starting to catch up. Jack talked about it in the morning a little bit on where fiber investments are going. That has to change. And this is actually a very relevant conversation where if you look at the underlying infrastructure, it's not one or the other, it's a tiered system now. You have large-scale data centers, the ones that I was describing, 150 megawatts or more, which are out in the middle of nowhere, population 200 towns, and that's where the large data centers are, because that's where it's cheap to buy, build, and power is cheaper. Then you have the next layer where you are seeing the data centers that Equinix and others are building that are popping up in closer to the end users. And then you are looking at the edge where we're actually putting nodes inside of ISP networks. And then what Josh is trying to do is go even deeper, go to the mobile edge and go put it in the mobile space. So what you're going to see is you're going to see the tiered infrastructure happen, and the challenge will be back to the app guys where you're going to help is where can you actually take advantage of the different tiers and based on your service, use the right tiers, where do you want to run your service?
I live in the sub-hyperscale world where I deploy 10,000 servers a year in 20 markets. It's a really bad place to be. Well, it's not a lot, right? I mean, comparatively, right? The vast majority of server capacity goes to hyperscalers that deploy orders of magnitude of that per month, right? So I think that there's been a huge amount of innovation in the hyperscale data center world, and there's also been a massive amount of consolidation in the buying power and the supply chain that works around that. You know, numbers that I hear, and I don't know if they're right or wrong, is that, you know, major x86 chip vendor sells 50+% of its processors to sub 10 people, right? And there's a whole supply chain that's really, really focused on that market, right? So if you want to buy 100,000 plus servers per month, there's a really, really good data center and hardware supply chain to do it for you. I think that there has not been much innovation. I would say it's actually harder than it was 10 or 15 years ago when I first showed up in the data center world 18 years ago at NetAccess in New Jersey with Alex Rubenstein. Oh. And, you know, he racked it for me, and he actually loaned me the money, and he even gave me the switch. And that was really easy to put one server online. And now today, that's like, go to a data center, they're just gonna laugh at you and walk you out the building if you can find it, right? So I think that there hasn't been a lot of innovation in the sub-hyperscale model, and I would say that for enterprises or anybody below the top 20 customers in the world is actually not been much innovation. So I'm excited by what some people are doing around how the data center can look different. You can bring hyperscale knowledge around efficiencies, but bring it to a bite size and a chunk that's more usable to the rest of the world or different locations. But I think that's going to do exactly what happened in the hyperscale world, where you connected the hardware supply chain to the data center. They're not two different things. You design hardware around, you design your data center around your hardware, or the other way around, I guess, but they're done together. And we don't do that in the rest of the world. And I think that that's what's going to have to change, is that we're going to need to build a distribution model that connects the supply chain with the end place that it houses. Any other big consumerized business in the world does that. We're all going to get new iPhones next month. Like, they're going to show up in everywhere around the world, and people are going to use them, and my wife's going to have one, and that's not going to take 2 years to get into every market. But there's a huge supply chain that works on that. There's not the same thing in the data center market, I think, past hyperscaler. So I think we're going to see a lot of change.
So what I've learned listening to these guys is that there's a pretty big gap between the wired infrastructure that we have today and the demand that's coming from the wireless world. And it sounds like all these guys are doing something to take advantage of those opportunities, right? And at Packet Fabric, that's where I'm from, we're building an intelligent network that all the big data are being gathered and pulled into the world. We're trying to get all of that data put into work by using the latest AI and ML technologies to help businesses make better decisions. And Zach is working on building an edge compute platform to make sure that the smaller businesses, the sub-hyperscalers, I love that word, and are going to have a piece of the pie as well. And I know that Andy has just launched an edge cloud platform enabling hyperscale delivery of Akamai services from the Akamai edge. And lastly, Najim is making sure your experience with all of the Facebook services that you consume and provide into his ecosystem. So, world dominance?
No, I think it's cocktail hour.
So I think the last thing that I want to leave you guys to think about is, what opportunities do you see with this gap that we just talked about? That's pretty obvious. And what are you going to do to take advantage of that? And so with that, I think we conclude the session and thank my panelists, Andy, Najim, and Zach. Thank you very much for your insights. Cocktail is outside the door.